What's up, YouTubers? Jose Quiñones de CNC Do here. Hey, today I want to talk about power sources. What do we use to power up our three-phase BLDC motor drivers or pretty much any electronics board? When it comes to power supplies, there are basically two options. You can use a regulated power supply or you can use a battery. A regulated power supply is basically something that you plug into your line power, your wall outlet, 120 volts AC or 240 volts AC, and it is basically a circuit that transforms the AC input into a DC output and then steps it down to a voltage of your choosing. Regular power supplies or switching power supplies can be fixed or variable. This is an example of a fixed power supply. The output on this guy is 24 volts with as much as 6.5 amps, roughly 150 watts. This power supply will give me 24 volts continuous at all times, and as long as I don't exceed 6.5 amps, everybody's happy. That means that the current can fluctuate and it can be whatever the application needs, but I get my 24 volts out. This comes in pretty much any size that you can imagine in terms of voltage output and current capability. For example, I have one here that is 48 volts output, 12.5 amps. This is roughly 600 watts. But you know, it can be 5 volts, 12 volts, 36 volts, whatever you can find out there. Chances are any voltage and current capability has been designed, and if not, somebody will design it for you. These are examples of fixed power supplies. That means that the voltage is fixed and you cannot change it easily. You will need to play with another stage to change the voltage or to limit the current. So that's why there are also variable power supplies like the one that I use here on my bench. And the advantage of a variable power supply is that you can change the output. You can make the voltage go from 0 to whatever is the maximum voltage. In this case, this guy can go up to 60 volts with as much as 5 amps. Now this unit is a dual rail, so I can put them in parallel or in series, and I can get different voltage and current output capabilities. Be aware that the main disadvantage of the variable power supply is you're not going to get as much power as with a fixed power supply. For example, this power supply here is 300 watts, and look at the size of this thing, whereas this guy is 600 watts. They both connect to the wall, they both give me voltage and current, but what changes is whether you can modify the output. Okay? Now, these power supplies are great for powering up stationary loads. For example, if you have a milling machine, a lathe, any power tool that is gonna stay put, it's not gonna move, because you're gonna have to plug it into the wall. When it comes to mobile endeavors, like I have a little robotic platform here, you can imagine this guy's gonna be moving around. How am I gonna plug it to the wall? It doesn't make any sense. I need something that is mobile, and that's where batteries come in. Now, we're super lucky that there are a pentillion batteries out there to choose. 20 years ago there were batteries, but they were not as good as they are today. Here is an example, some power tools that I use on my projects. This is a Milwaukee brushless an impact driver. This is the Craftsman C3 version. And these are fantastic tools. They're mobile, and because of the amazing lithium ion battery technology, they last a long time. With the older chemistries that we had before, the NiCads, the NIMs, the nickel metal hydrides, and the nickel cadmium batteries, they did the job, but they were not very good. So this technology has improved a lot, and this allows us to basically power up a tool that does not need to be connected to the wall. The problem, however, is interfacing to them. But let me talk about that in a little bit. First of all, I want to say, these batteries are great. They have different things that a power supply cannot give you. Mobility is one of them, but also current capability. This is let's see, this is a 2 amp hour battery. This one is also a 2 amp battery, I believe, but they come in all different sizes. Also, they come in different voltages. This is a 56 volt battery, 5 amps hour, but do not be fooled by that. I mean, 5 amp hour means that if I were to draw 5 amps out of this battery continuously in an hour, I would no longer have 56 volts. Actually, that's in reality is different. It's much less. I mean, most likely at 5 amps in an hour, the thing will be depleted. But the beauty of these batteries is that they can give you ridiculous currents instantaneously. Let's say this tool requires 100, 200, 300 amps to do what it needs to do for a few microseconds or milliseconds. The battery can do that. The battery can say, here, take the current. The power supply cannot do that, because the power supply, once it reaches its maximum current, that's it. That's when it stops working. At that point in time, it says, okay, I'm done. The power supply is most likely going to shut down. The voltage is going to decrease. It's going to plummet, and your application is going to collapse. Okay, so that is the advantage of the battery. I mean, those are the two main advantages of the battery: mobility and availability of current. The problem is, how do we interface the batteries to our circuits? I mean, a power supply, it comes with these very nice terminals. I can screw my wires in, and everybody's happy. But a battery, it's not that easy. The other problem is that all of these batteries are tied to the vendor. I mean, this is a Milwaukee, Craftsman, Ego, Stanley Black & Decker has one, Harbor Freight has like 2 different ones, and they're all 100% uncompatible in terms of the connector. When you look at the connector, the way that the terminals are built are meant to power up the tool. So that is a problem, and it's not impossible to solve, but basically it requires you to find a counterpart to the battery so you can get access to the terminals. I forgot to say, another cool thing about these batteries is that they have all of the protection that you need. They have the charging circuitry, so they have their own chargers, so you can charge them easily, and they're protected from all sorts of different things, because you really don't want one of these batteries catching fire. That would be really, really, really bad. So how am I going to tackle the access to the terminals problem? I'm gonna take one of my, I'm gonna use one of my Craftsman C3 batteries, because as it happens, I got one of these chargers on one of my Black Friday incursions, where you can buy a drill for 40 bucks and you basically keep the battery and toss the drill away. But I got this guy, which I don't use because I have the bulky chargers, which are far superior. So this guy is going to give me access to the terminals, and this is what I'm going to use to power up my board. Let me show you. So I took the charger and I unscrew, there are 4 screws, and I literally use the same power tool to unscrew this guy. I'm not going to need that. What I'm going to need is this guy. As you can see, there is some circuitry here. I imagine that's the circuitry required to charge your battery, because I mean there is some talking with the battery and there is some coordination of power. This is a charger exclusively for lithium ion batteries, so you cannot use it for any other chemistry. So what I'm going to do, I'm going to unsolder this board, which I don't need, and I'm going to tap into this guy. And the beauty is that I will be able to put this guy back, and obviously like this, and then boom, here is my battery, and here are going to be my 2 wires which I'm going to plug into my board. Alright, I was able to desolder this guy. I gotta say, this was a little bit tougher than I expected, and the problem is that there are 3 points, and you know, these are tough to desolder. You gotta suck all of the soldering, but there is always some that keeps plug, and eventually I was able to, but it wasn't 100% easy. Then came the realization that I completely forgot whether this goes like this or like this, but luckily there is a little bit of a feature here, and let's see, yeah, there is a little bit. Actually, this goes like this. It cannot go any other way. So I'm glad the craftsman designer or whoever, well, look at that. It is a TTI. TTI is what it says in there. So that means that TTI makes this tool. I'm glad that they did a good job, because you really don't want to put this backwards. Now, of course, there is only one way of putting this back. And that means, you see, there is only one way of putting it back. So they did a good job. So you basically cannot put this backwards. If you put this backwards, man, you're just gonna kill something. So it is crucial to have it correct, because notice that this guy goes like this, but if for whatever reason those two guys were backwards, although mechanically it can only go like this, electrically it will be backwards, and you will be putting negative voltage, and everything on the drill or the tool will vaporize at that point in time, because I completely doubt they have any kind of protection for backwards. It's just the currents that we're dealing with here would be too much. So that is why they did it like this. So it is basically impossible for you to apply negative voltage. Right, so now all I have to do is solder two wires. I gotta be very careful with how I do this. Luckily, this is super well documented. As you can see, B minus, B plus, that is battery ground and battery voltage. So I will put my black wire on B minus, my red wire on B plus, and everybody will be happy. All right, we're basically done. I was able to close this guy up. I had to use the LED hole in here because, you know, these wires are far thicker than the wires that were coming in. So before they were coming in, now they're coming out. And now I'm ready to put this guy in. Let me give you a piece of advice. When you make a hack like this, make sure that you got your connections right before you plug it into your system, because, you know, I'm assuming that B plus and B minus mean plus and minus, but here is my piece of advice. Always assume that you should not assume anything. So I'm gonna test to make sure that plus is plus and minus is minus, as I was suspecting. And sure enough, I'm getting my positive voltage, 17.26 volts on the battery as we speak. That means that, you know, this is plus, this is minus. It should be okay to plug in my circuit now. So my assumption was correct, but, you know, it could have been wrong. So always assume that you should not assume anything. And now we're ready to power up. We have lights. That means that the system is ready and it is fully powered from a battery. Well, YouTubers, I hope this quick tutorial on how to power up your device has been helpful to you. Feel free to ask questions on the comments below if there is any item that requires further clarification. But I hope that this can get you going on how to power up your devices. Thank you for tuning to my YouTube channel, and I'm gonna see you on the next time.